Hello, and welcome to the second video in the Hurricane Hazard series for South Carolina's Hurricane Preparedness Month. My name is Samantha Trellinger. I'm a meteorologist here at the National Weather Service in Charleston, South Carolina. Tropical cyclones can bring a variety of hazards to the Palmetto State, which can be felt hundreds of miles from the coast. These hazards can include strong winds, tornadoes, heavy rainfall, and flooding. The coast can also be impacted by storm surge, dangerous waves, and rip currents. Our office has teamed up with the other three offices that serve the state of South Carolina, along with the State Climate Office, to bring you a 5-part video series on these hazards. Today's video will cover storm surge and coastal impacts. Storm surge from tropical cyclones pose a significant threat to life and property along the coast and is currently the leading cause of fatalities from hurricanes. All locations along the U.S. East and Gulf Coast are vulnerable to storm surges. While impacts along the coastline can be devastating, it's important to note that storm surge can even travel up rivers and canals, reaching well inland. An example of this can be seen on the right during Hurricane Katrina in 2005. Storm surge was able to travel 10 miles inland across portions of Mississippi. Thus, awareness of the destructive potential of storm surge is crucial for improving safety and resilience in coastal communities. So, what is storm surge? Storm surge is defined as an abnormal water level rise generated by a storm over and above the predicted astronomical tide. You may also hear the word storm tide used, and this is defined as the water level rise during a storm due to the combination of both storm surge and the astronomical tide. So in this image, we see this white line along coast saying mean sea level. We also see this 2-foot normal high tide, so that would be considered our astronomical tide. We notice our 15-foot surge, and then our storm tide, which is a combination of the two. So our 2-foot astro tide plus our 15-foot surge would equal our 17-foot storm tide. For the purpose of this video, we are solely going to focus on storm surge. So what causes storm surge? Storm surge is caused primarily by the strong winds in a hurricane or tropical storm. The highest surge tends to occur near the radius of maximum winds, or where the strongest winds of the hurricane occur. It's important to note that the low pressure of the storm has minimal contribution to storm surge. Rather, the maximum amount of storm surge for a particular location depends on several factors. Storm surge is very complex because it is sensitive to the slightest changes in storm intensity, forward speed, size, angle of approach, and shapes and characteristics of the coastline, which we'll get into in the coming slides. To start, stronger winds will produce a higher surge. In terms of forward speed, a faster storm will produce a higher surge along the immediate coast, whereas a slower storm will produce a surge that penetrates farther inland. Looking at this first example, we note a faster storm. As a result, we are seeing a higher storm surge denoted along the immediate coast. So those areas shaded in red signify a storm surge greater than 9 feet above the ground. We do see some storm surge pushing inland, but it is greatest along the immediate coast. Whereas in the second example of a slower storm, we still see areas of 9 foot or greater along the immediate coast, but as we move inland, we're starting to see some of those oranges and yellows further than we did before. You can even notice that areas like Lake Charles are even experiencing storm surge near 3 to 6 feet, whereas previously with the faster storm, since it was more focused along the immediate coast, we only had a storm surge near 1 foot. So a faster storm is more impactful along the immediate coast, whereas a slower storm can penetrate further inland. Next, moving on to the size, a larger storm will produce a higher surge. Winds in a larger storm push on a larger area of the ocean, and thus they're able to bring more water on shore. The strong winds in a larger storm will tend to affect an area longer compared to a smaller storm. And this can be seen in this video. The top video denotes a smaller storm, as seen by this square, versus the bottom, which denotes a larger storm. And the top, the smaller square, is interacting with less water and thus pushing less storm surge on shore. So again, when we look at the bottom video, we see the larger storm. It's able to interact with a larger portion of the ocean and thus push a higher storm surge on shore. Next, we'll focus on the angle of approach. The angle at which a storm approaches a coastline can affect the amount of storm surge pushed over land. A storm that moves onshore perpendicular to the coast is more likely to produce a higher storm surge than one that moves parallel to the coast or inland at an oblique angle. So we'll start with one that moves more parallel or at an oblique angle. As seen on the image here in the left, the white line denotes the storm motion of the tropical system or hurricane. So in this example, the system is moving from the southeast to the northwest and approaching the state of New York. If we look at the orientation of our coastline, we note that it is more of a south-southwest to a north-northeast, which is denoted by this line here. So as you can see, we are at less than a 90-degree angle. In terms of our storm surge flooding, we do see areas along the coast ranging from 3 to 9 feet, but it is less noticeable compared to an example that we're going to show here on the right, which has a storm moving more perpendicular. So the white line again represents the motion of the storm. So this storm is more oriented southeast and it's moving northwest. And then we have again our orientation of the coast, which is south-southwest to north-northeast. So we have more of a 90-degree angle or perpendicular approach. Thus, if we compare the storm surge flooding, we notice that there are areas along the immediate coastline that are now approaching 9 feet or greater. And if we look just southeast of New York along these exterior islands here, we notice that before there was only about a 1-foot surge forecast, whereas this angle of approach would suggest upwards of 3 feet. So again, parallel moving storms usually produce less storm surge, whereas those moving perpendicular to the coast often yield a higher storm surge. Next, we'll move on to shape and characteristics of the coastline. A wide, gently sloping continental shelf will allow for a higher storm surge. In contrast, a narrow, steeply sloping shelf will allow for more difficulty creating storm surge. So looking at a gently sloping shelf on the left, in this video we can see a wave approaching the coast, and given the gentle sloping nature, there's not a lot of resistance to the wave moving on shore. So the storm surge has no problem pushing inland. So areas along the Gulf Coast, especially Louisiana and Mississippi, are particularly vulnerable to storm surge because the ocean floor gradually deepens offshore. Now, if we look at the example here on the right of a steep sloping shelf, we see that a wave will push towards the coast. However, given that the slope is so steep, it's not able to crest onto the beach, and thus storm surge is harder to create. So areas along Florida's southeast coast, for example, have a shelf that drops off very quickly like this, so they are less susceptible to storm surge. Continuing with the shape and characteristics of the coastline, storm surge will be higher when a storm makes landfall on a concave coastline versus a convex. So a concave coastline is one that caves inward, like the shape of a C, versus convex, which is a coastline that bows outward. Storm surge is also highly dependent on local features and barriers that affect the flow of water. A great example of this is the image on the right, which is on the outer portions of the North Carolina coast along the barrier islands, where there are multiple sounds, bays, and inlets where water can flow. Now, in reality, storm surge only makes up part of what causes water levels to rise along the coast during a hurricane. There are other factors to include, which are tides. So the water levels rise and fall along the coast every day due to the gravitational pull of the moon and sun. We also have waves in general. Breaking waves contribute to the water level rise through wave run-up and wave setup. And lastly, we have our freshwater input. So heavy rainfall ahead of a hurricane can cause river levels to rise well inland from the coast. So all of these factors combined are what's called total water level. So total water level, again, is the combination of storm surge, tides, waves, and freshwater input. So what are impacts that we commonly see from storm surge? Large areas are often covered with deep water due to storm surge flooding. Structural damage to buildings is common, with some washing away entirely. Some locations may be uninhabitable for an extended period of time. Large sections of roads could be washed away or severely flooded. And lastly, major damage to marinas, docks, boardwalks, and piers could occur. So, how can you prepare for a storm surge in the future? The first step would be to determine if you live in an evacuation zone. This is important if you live in the area or if you're visiting a tropical area, especially in and ahead of tropical season. If you do live in an evacuation zone, we tell folks to look at several routes ahead of time. If an evacuation order is issued, there's going to be quite a bit of traffic congestion as multiple people are going to be heading out the same exact path you're going. So potentially having other routes could be useful. Having a go bag for supplies would be your next step. Items in your go bag could include your ID, your passport, your insurance, any medications or medical records, clothing items, comfort items. So this can include pillows and blankets, having some non-perishable food items in addition to water and batteries is also great. If you're traveling with younger kids, having some snacks for them or some toys and books, anything that you would not want to leave the house or forget in the event that something were to be flooded or have a storm surge approach. In addition to packing for yourself and others of your family, it's important to include your pets in your plan. You could also bring comfort items for them. So this could include beds and blankets. Make sure you bring adequate water and food. And if they're on any medications, be sure to pack those as well. And lastly, we encourage folks to follow any evacuation orders given. To monitor these orders, you could look on social media at your state's local emergency management page or on any of the local news stations as they will be broadcasting that as well. You could watch TV networks. Again, with the broadcast media, if there's any evacuation orders, that's likely going to come across and potentially interrupt any show you're watching. Or you can hear orders across a radio. So there are different avenues that you should be monitoring if there is inclement weather coming to your area, especially if a storm surge is forecast to arrive. So this concludes the second presentation in the Hurricane Hazard video series. Our next video will be on heavy rainfall and inland flooding and will be posted to NWS Columbia's YouTube page sometime next week. In the meantime, if you have any questions or concerns, you can find us on Facebook and X with the tagline NWS Charleston, South Carolina. Some of our video content can also be viewed on YouTube. Otherwise, feel free to visit us at weather.gov/CHS to get your latest forecast and any other needs for your area. Thank you for watching.